Well, there is also this thing that you always face in measuring things in physics. Sometimes we are talking about, well, precision of your measurements. Sometimes you are talking about the accuracy of your measurements. So what are these words, precision, accuracy? Are they the same thing or different? Well, in fact, they are different. There is a difference between these. It might look to you that okay, precision, accuracy, they are meaning is almost close to each other, and you can take one of them in place of the other one, but it's not true in terms of physical jargon. So in fact, there is some difference, an important difference between precision and accuracy. So let me explain this on an experiment. So what you see over here, a man, okay, with shoes, standing on it, and its height is going to be measured. Its height is going to be measured several times using a very precise device like a laser device. There are some laser devices that measures lengths in a very precise way. So all the measurements were done, and it's very similar to each other, and always it gives you all measurements. It gives you this value, 184.34 centimeters is the measurement value. But if you're doing this, repeating this several times, if always you're using the same value, and what we say about all these measurements, that we can say that your measurement is very precise, because each time it gives always the same value. So it's very precise. Okay? So, this is what it means in terms of an example. Multiple measurements, always you get the same results, but sometimes you might have a very small difference. For example, one measurement might be 184.33, let's say. But still, they are very close to each other. Almost the same result or close to each other. Then your measurements are precise. Okay. So this is what it means by precision. But if you're a little careful about this measurement, you will see that in fact this is not the true height of this man. Why do you think so? Because he wears shoes, right? He must take off his shoes. If you remember that when you go to the hospital, first thing that they measure your height and your blood pressure, etc., and also weight. They require you take your shoes off, right? Because with the shoes on, it's not going to be your accurate or true height. So the accuracy is about this. The accuracy is about you require the man take off his shoes. The measurement with the shoes on are precise. They might be precise, but they are not accurate because he wears his shoes. So if you require that the man takes his shoes off and do the same measurement again with the same device, then your measurements will be accurate, because it's going to be, these all measurements is going to be very close to true value, true height of the man. Okay. So you see now, it appears that there is now some difference between precision and accuracy. All right. So, all right. Well, the men take the shoes off, but this time you're not given this very precise laser device, but you're giving this a tape measure or a ruler. And since you don't have a very precise device, then the precision, the measurement of the precision, in fact, will reflect itself in this measurement value. What you see over here with the ruler, your measurement value 181. There is no decimal point after the last digit. Why? Because you changed your device. Okay, this is a rough device in compared to laser device. But if you repeat this measurement many times with the shoes off, then these measurements might appear more accurate than the measurements which is done by a laser device with the shoes on. Okay, so Well, you might have more accurate results even with the rough devices. If you know how to measure the things, then you might get still accurate results. But it's going to be less precise because there will be more variations. Why? Because you might have one measurement reading like 180, and the other measurements might be like 182, but the variation it's going to be plus or minus 1. So there's going to be more variation of 1 centimeters. So these variations mean that, or the uncertainty, your measurement will not going to be precise as this laser length device. Okay. All right. So of course you can have a measurement which is very precise and at the same time which is very accurate. This is the true goal of all measurements. In fact, you have to you want to get very precise measurements. Also at the same time you want to get very accurate measurements. Okay, so this result, for example, is going to be again this man's height, but taking shoes off and using the laser device. All right, and this measurement is going to be both very precise, because that the laser device is always giving the same value. You have done this many times, and since you know that the uncertainty is very small for this laser device, that means that the variations is going to be very small. That means it's going to be accurate, right? So it's both accurate and it's precise. It is possible to get both at the same time. Well, you can see this on a graph like this. Okay. For example, you're playing this dart game. Okay, and you throw your dart many times to this target, and what you see over here, this one and this one. So averaging this shoots and this shoots will give you the same geometrical point, right? That means both this and this is going to be having the same accuracy, because averaging this and this geometrically will correspond to almost the same point, right? But let's have a look at this one. This one, the top right corner. Well, your shoots are very close to each other. That means that corresponds to measurements are very close to each other. It's precise, but the thing is, it's not accurate because they are way off the center of the target, right? And if you look at this bottom right, it's even worse, because they are not precise, because these darts are not closer to each other, neither closer the average closer to the center. Okay, so this is not accurate, not precise. This is accurate but not precise. This is both accurate and precise, and this is precise but not accurate. All right. So graphically, this I think will explain the things very neatly to you. All right. Well, there are types of errors. One type of errors is called random errors. What are these random errors? These are, uncontrollable variations in the measurements. For example, many people are doing the same measurement, but since these measurements are done with different people, most probably the measurements will be differing to each other. Okay, but some people will get a larger in compared to the true value, accurate value. Some people will get a smaller value. So this difference is going to be random. It's not going to be like always there all these people measuring the measurement always larger than its accurate value. Then we say that it's not random error. Okay, random error is going to be less, sometimes it's going to be less than the true value, sometimes it's going to be larger than the true value. And the reasons are, as I said, it might be doing by different people, it might be doing by different techniques. The reaction times of the people might be different, and the techniques that these people might be poor, right? But if you have random errors, there is always a way to reduce or decrease the magnitude of these errors by doing the measurement multiple times. If you do this measurement multiple times and take the average, and you will see that the errors will get, these random errors will smaller and smaller, okay? But the second type of errors are called the systematic errors. As I said, the systematic errors, for example, if there are many measurements, or all measurements are giving the values always larger than the accurate value, then you can say that there is a systematic error in there, okay? It's going to be almost all the measurements are bigger or smaller than the true value. And it is not possible to decrease the systematic errors unless you're changing your device or something, okay? So, might be, normally caused by not measuring from zero. Example is that, remember this guy, measurement of the height of this guy, with the shoes on. So whatever you do, whichever device you use, all the measurements are going to be always larger than its true value. So you understand that there is kind of systematic error, and then you have to change the way you measure. You have to change either the subject, or you have to change, it might be also that your ruler might be, or your measuring device, length measuring device might have some errors, might be the labels are not evenly spaced, or etc. All right, so, and what are the ways to state uncertainty? What you see over here, for example, 1563 plus minus 5 millimeters is a length measurement, and this is the measurement, this is the measured value, and this is the uncertainty in your measurement, or error in your measurement. But this is called, this way of writing the measurement, if you see plus minus sign, this part is called the absolute uncertainty, okay? But if you just divide this number by the measured value, what you get, this number, and if you multiply that by 100, you will get a percentage error, okay? If you do this operation, all right, then you can always write down this measurement as your measured value is 1563 millimeters with an error of 0.3%. With the 0.3% error, you can state you have this measurement. It's also going to be same thing with this one. So there are two ways of recording your data. And this is called data, because data contains both the measured value, and let me write it down, okay? This is all this thing is called data. This is data. And the first part in your data is the measured value. Sorry, let me write it over here. Measured value. Here the measured value is 1563. And the second part of your measure after plus minus sign, this part, is the error value. But if your recording of data is this way, you're writing error, this error part, as the absolute error. But if you're recording your data, and let me write it over here, 1563, with 0.3%. This is also another way of writing this data. Okay, this way you state the uncertainty as a percentage, and this is the percentage error in this measurement. You either record your data with the absolute error, or you record your data with the percentage error. So there are two ways of expressing your data. Okay, this completes our lecture.